It's always good to see a model based on thorough research. In this video, we are going to have a look at this new model called as Armo RM, which is a reward model that outperforms GPT-4 in few of the benchmarks. In this video, we are going to install it and then we will also see a demo of it. Before I show you the installation, let me take you to its architecture because it's always good to understand what is happening behind the scene when it comes to a model. So, reinforcement learning from human feedback or RLHF has emerged as a primary method for aligning LLMs with human preferences. The RLHF process typically starts by training a reward model, which is also called as RM model, and this starts by using human preferences data. When we say human preferences data, it means that, for example, there is a question and there are two answers. One is a human preferred answer and the other might be a rejected answer. So that is how when we present this data to a large language model then is trained on human preferred data, and that is how it gets aligned to human preferences. Conventional reward models are trained on pairwise responses to the same user request, with relative ratings indicating which response humans prefer. The trained RM serves as a proxy for human preferences. But due to the black box nature of reward models, their outputs lack interpretability, as humans cannot intuitively understand why an RM thinks a response is good or not. As reward model acts as human preference proxies, these researchers believe that they should be human interpretable to ensure that their internal decision processes are consistent with the human preferences and to prevent reward hacking in LLM alignment, and that is what you're looking at your screen in this architecture at the moment. Also, to build these reward models with interpretable preferences, they have proposed a two-stage approach. First, train an absolute rating multi-object reward model or ArmoRM with multi-dimensional absolute rating data, each dimension corresponding to a human interpretable objective, which is honesty, verbosity, and safety. Secondly, employ a mixture of expert strategy with a gating network that automatically selects the most suitable reward objectives based on the context. They have also efficiently trained on ArmoRM with Llama 3 8 billion and a gating network consisting of a shallow MLP on top of the ArmoRM. And this model, which is a reward model ArmoRM Llama 3 8 billion, ranks first on the leaderboard of Reward Bench, which is a benchmark evaluating reward models for language model. Also, the performance of their model surpasses the LLM as a judge approach using GPT-4 and also the common Bradley-Terry modeling approach with Llama 3 8 billion or G34 billion by a wide margin. Okay, so enough theory. Let's try to see how it works after installation. And before that, let me give a huge shout out to Mass Compute who are sponsoring the VM and the GPU which I'm using for this video. If you're looking to rent a GPU on affordable prices, I'm going to drop the link to their website and also a coupon code which you will use to get a 50% discount on range of GPUs. Okay, so let's go to that VM, and that VM is Ubuntu 22.04, and the NVIDIA card which I'm using is this NVIDIA RTX A6000 with 48 GB of VRAM. Let me clear the screen. Also, I will be using Conda to create a separate virtual environment. Let me create that environment. I'm just calling it ArmoRM. That should be done, and it is also activated. Let me clear the screen. Let's install PyTorch and transformers, which are prerequisite for this. Let's wait for it to get installed. Shouldn't take too long. Both the prerequisites are installed. Let me clear the screen. Let me fire up my Python interpreter, and then let's import PyTorch and transformers. Both are done. Let's set our device to CUDA because I'm using GPU, and I would suggest that you also use the GPU. Let's give the path to the model, which is primarily the repo for where Armo RM is present. And now let's grab our model with the help of these parameters. So if you look at this command, I'm just using auto model for sequence classification, and then I'm providing it the device CUDA and also the model here. So let me run it, and it has started downloading the model. There are 4 shards of it, and it seems each shard is around 5 gig. So let's wait for it to get downloaded. And the model is downloaded, and also it has loaded it onto our GPU. So that's done. Let's also get our tokenizer. And tokenizer is also done. Let's specify a prompt, and these prompts which I'm going to use are in the model are from the help steer dataset. Help steer dataset is designed to help AI models learn to understand and respond to user queries in a helpful and informative way, much like a human assistant would. And this dataset contain a large number of examples of human like conversations, like question answers. So help steer dataset is really good. If you haven't used it, I will highly suggest to check it out. So there you go. So you see, I have just um, asked it a question or prompt that what are some synonyms for word beautiful, and then the response is nicely, beautifully, handsome, and all that stuff. And then let's create a prompt template out of it. That is also done. Let's send it to tokenizer to convert these text into tokens, and that is done. Let me press enter a few times, and now look at this code. This code is quite interesting. So what is happening here is that in the first one we are giving multi-object rewards for the response in the multi-object rewards, and then the getting layers output is conditioned on the prompt, and then the preference score for the response aggregated from the multi-object rewards with the getting layer is being done at the end. That is also done. Missing stuff. And now let's apply a transformation matrix to the multi-object reward before multiplying with the getting layers output, and this mainly aims at reducing the verbosity bias of the original reward objective, and this is what we need to do for it. We just simply transforming it, and then the final coefficients assigned to each reward objective easily. So let me also put it here, and that is done. And now let's also assert, and what we are asserting here is that the preference score, which is a linear combination of the multi-objective reward with the multi-objective coefficients, which can be verified by the assertion which we are doing now. So we have done it. Also, let's find the top k reward objectives with coefficients of the highest magnitude. I'm just defining top k as 3, and then let's also get the top objective dimensions. Let's get coefficients too with the same command. That is also done. And then let's also get the attributes of the 19 reward objectives. I would need to paste those here, and these are the objectives. Let me paste first, and these were the objectives which you need to check. And in order to check, let's loop through it, and then it is going to print. So you see the code complexity is this is the help steer verbosity, and then this is the ultra feedback instruction following, and this is all on the basis of this attribute and the question which we asked above, this question and these responses. Also, if you like, you can go with help steer reward predictions, which are the actual rewards, and you can see these are the reward values, and so these are the actual reward from the help steer data set, and these are for 5 help steer objectives, which are helpfulness. So this is a helpfulness, this is a correctness, this is a coherence, and this is a complexity, and this is a verbosity. And we can also linearly transform this predicted reward to the reward space with the help of these tensors which you are seeing here. So all in all, this is the reward model, and it is quite easy to see when you ask these questions, and then you can measure them according to this attribute. And this is quite flexible, so you can go with any data set of your choice. Limit sky is the limit here. So all in all, a really great rating reward model, and this is absolute rating, which is not that tricky to implement. So I believe that if you're looking to implement it in your own pipelines with your training and fine tuning. This is quite interesting. That's it, guys. I hope that you enjoyed it. I'm going to put the link to this model card in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, please share it among your network as it helps. Thanks for watching.